All right, boys and girls, welcome back to the drive-thru for a special sequel, the first ever sequel to 7.4, the return of the regular polygons. Okay, as always, sponsored by the deli. Hungry? Stop by the deli. And, I don't know, get yourself a sandwich. All right, so a regular polygon is a polygon that is both equiangular and equilateral. So, we have confused you, because what did we call this triangle right here up until now? We called it equilateral, or we said you could call it equiangular, and we should have just told you that it was regular. That's a regular triangle. Okay? What's the sum of the measures of a triangle? So what's each one of these angles? 60, 60, and 60. Okay? What's the sum of the measures of a quadrilateral? So what's the measure of each of the angles? Well, you already knew that they were 90, but maybe now you understand why they're 90. Okay? It just happens to work out that way. So, today you will be faced with the challenge of, what's the measure of an angle of a regular 72-gon? It's not that big of a deal. How would you do that? 72 minus 2 is 70. 70 times 180 is whatever, and then we'll take that humongous sum of all their angles and then do what? Divide by 72. So that's basically the whole lesson. No big deal. So I'll walk you through that, and then hopefully I'll teach you a little bit more than that. So let's look at a new regular polygon, a regular hexagon. How many sides does a hexagon have? So what's the sum of the angles? Well, it's 4 times 180, right? Which is 720. And so if this is a regular hexagon, how are the angles related? They're equal, so how do we find each one? 720 divided by 6, and that is indeed 120. So, what's that make each exterior angle? That makes each exterior angle 60. Well, that's good, because what's the sum of the exterior angles always in a polygon? It's 360. And how many exterior angles are there? 6, and 360 divided by 6 is 60. Oh, well, hold on. That's a new way we could find the interior angles. We could go about it a totally different way. You could find the measure of an exterior angle, and then do what? Subtract, find the supplement. Subtract from 180. Excellent. Okay, so now we should have our rules. Okay? In an equiangular polygon, the measure of the exterior angle, or one exterior angle, I should say one exterior angle. The exterior angle of a regular polygon is equal to what? 360 divided by n. Excellent. Where n represents the number of sides in the polygon. Okay? The interior angle, as we stated before, just like someone said, you could find the supplement of the what? Of the exterior angle. So you could do 180 minus 360 over n. What's a completely different way to find the interior angle? Find the sum of the measure of the sides. How do you do that? And then do what to find the measure of each angle? Divide by n. And, you know, amazingly enough, these two things obviously equal each other. Okay? So far, so good? Huh? So, let's do this. All right, go ahead. Find the measure of an interior angle of a regular 1002-gon. Okay? And while you do that, I'm going to draw it for you. Okay? What do we get for the interior angle? Interior angle is what? 179 point, and therefore the exterior angle is? Okay, and that's where both of those are rounded, okay? I understand that both of those are rounded. So pay attention to this. I don't know what you guys are doing. I know you're done with your homework, but I want you to learn this. So I don't care what you're doing. You're stopping it for now, and I don't always ask you to do that. Okay? So, look, you either don't believe in infinity, like you believe that it's stupid and it's not worth thinking about because we can never get there, which is what my son thinks. He's 5. He doesn't care about infinity because he can't count that high. Does that make sense? So to him it does not exist. Or, so you either don't care about infinity or you don't believe in infinity, or you don't believe in circles. You cannot believe in both. Okay? I'm sorry. You can only believe in both. You cannot believe in just one of those two. That's what I'm meaning to tell you. Because here's what we're learning. See, I don't think you realize it. You just come up with an answer. But what we're saying is that in an 1000-gon, if this was 1000-gon, and we zoomed into it, mega zoom with a microscope, or let's say that we were thinking of 1000-gon that was the size of the Earth, and you were standing over one of the intersections, what you would actually see if I took this thing right here, and I zoomed in on it on the next screen, that is a 179.6 degree angle. Can you see that? And if we had 1,000 of those, eventually they would meet back where they started. Okay? So, what is the biggest possible angle that you could form on the inside of a regular polygon? Okay, so it cannot exceed what? It cannot exceed 180. So that's a limit process. And so that means that the limit as n approaches infinity of n minus 2 times 180 divided by n is equal to 180 degrees. That's a calculus problem right there. But what that's saying is that infinity does exist, because when n gets to infinity, then our exterior angle will no longer be less than 180. Our interior angle will no longer be less than 180. What will it be? It will be 180, and when that happens, you will have your circle. That's how circles happen. That's what I'm telling you. You cannot believe in one or the other. If you believe in circles, then you have to believe in infinity. Okay, now none of that really matters, because like my son said, you can't count to infinity. You'll never get there. But here's why the consideration of infinity matters. Because inside of you are things that are so small that you can't even right now come close to understanding them. And you are also a part of something that is so big, right now you can't even come close to understanding where you fit in. So I'm just going to show you a little video that kind of highlights that. Every time you see a circle in this video, the amount of space has just gotten 10 times bigger. Okay? And I'm totally just stealing this guy's YouTube video, so maybe mine will eventually get taken down. I don't know how the rules on this work. But I'm going to leave it up there for you. Henry, why don't you hit the lights? So that circle is 10 times the size of the Earth. And now that circle right there is 100 times the size of the Earth. You feel me? All right. You just watch and enjoy. You can watch it at home. See ya. Go ahead and hit the lights. No. I haven't graded it, Max. I'm making a video right now.